Hello, in this tutorial we're going to talk about how to curate a new single gene display and also how to go about editing previously curated ones. So to jump right in from the My Workspace dashboard, I recommend signing in for the ability to utilize all the features of the gEAR. So if you haven't already signed up, feel free to sign up. You will have to do an email verification for that. Um, if you already have signed up, please feel free to sign in. So over here on the left-hand side, under our Analyze section, you'll see the single gene displays. We're going to click on that. At the top is the guide button that you've clicked on here. And our first step is going to be to select a data set. If you haven't utilized any of our analysis modules yet, all of the analysis modules will follow the same drop-down design. This is new to the gEAR 2.0 interface, and so you can see here it's going to follow the same things that other analysis modules will. So first we're going to select our data set. We're going to select a public data set, and you can choose whichever data set you want to. I'm going to stick with this 4 to 6 weeks mouse single cell RNA-seq, the utricle ATO1 transduced supporting cells from Groves. When you click on that, you'll see here at the top there's either a create new or load existing curation. You can curate your new display here. You can set as defaults, or you can clone the data sets as well. So we are interested in curating a new display for now, so we'll click on that. This takes just a second to load the information needed, and then here we can select a plot type. You can select a bar or scatter, violin, and then if there's tSNE or UMAP coordinates, you can select the tSNE UMAP as well. There's also tSNE static, UMAP static. So I will show those a little bit later in this demo as well. But we're gonna stick with a violin pot. We'll keep the primary analysis as default, but if there are other analyses done by, say, the single cell workbench, you can select those as well. So for genes, let's keep this simple. Let's just do a SOX2 search. Our x-axis is going to be group. When we click down, there's only group here. For other analyses, if there's other categories that they have, you can select those. Expression, color, we're going to leave default, annotation labels, subplots, or else everything else is just going to be default. Then we're going to click on plot. So it redirects you to a new page, and here you can see the violin plot. This is an enlarged version of what you would see in a dataset collection. So the dataset collection might show a slightly smaller box, but for now this is perfect for what we need to ensure that our display looks how we would expect it to for the dataset we've chosen. As you go through, you can further choose other options. So there's dataset filters, there's the plot configurations, which have all the parameters that you previously chose. And there's also changing of the sort order here. So if I expand all of these, on some of the larger datasets or some other datasets at all, you might be overwhelmed with the number of options. So being able to click on the arrows in order to both expand and contract the menu. So if I go to dataset filters and look at the groups, I can actually filter out like one of the groups if I want to. This will take a second to load. You'll see it added up there. If I hit update plot, once again, now we only see the one. Unselecting that, clicking update plot will bring back the other option. Going into plot configuration, if I wanted to change the X or Y axis, the color, or the marker size or the subplots. I can change all of those options. Those were all left as default, so I will leave them as default for this demo that I'm doing. I can also change the gene as needed. Changing the sort order, so if I wanted to change the order that they showed up in, I can change that. And then colors. If I'm happy with this display, I can choose to save it, so I'd have to supply a name. And so we could say demo violin. I can make this my default display. I could save this as a new display as well. You can also download the config file as a JSON in case you're interested in exactly how this is set up. You're also able to download this plot as a PNG if you need to. If this plot was any larger and you needed to pan it, you can zoom in and zoom out, and then of course reset the axes. So let's show some other options in the single gene displays. So I'm going to go back. I re-click on the single gene displays on the navigation bar so that I can choose a dataset that should have a tSNE UMAP section. So we can see here that the displays by the dataset owner, we can see that this is a UMAP static. So I know that there are UMAP coordinates here. So we'll create a new dataset. And here you can choose bar line scatter, the violin, and we can see both a tSNE UMAP dynamic or a UMAP static. To show the differences between those, I'm first going to start with the tSNE dynamic. And let's go with 808, which is in this data set. When working with these UMAPs, often you'll see something like UMAP 1, UMAP 2, X UMAP 1, X UMAP 2. Sometimes you just have to play around to figure out exactly which ones will present the data. So we'll go by cell type. For color, and as you can see here, we actually have a UMAP. Let's expand that a little bit so that that shows up. We can see here the UMAP. This is kind of a stretched UMAP. However, remember that this box will be slightly smaller for the dataset collection, so it won't be as stretched out. Now when we look at the dataset filters, there's a couple more options here. We can filter by the actual cell types. We can actually filter by hex codes, which is not extremely useful for this tutorial, but might be useful if you know the hex code for the color. And then the Louvain is just the same labels. So if we wanted to filter by the cell type, we can. We can update now, so marginal will not be there, so this reddish color. And we'll update, and now we only see the marginal. Update plot, and it comes back. If you want to select multiple, you can. So let's select quite a few of these, update the plot, and now you can see them as there. Unselect them all, update the plot so it's back to our original. We can go to plot configuration. We can change the gene again. So if I wanted to look for our POW2 F1 instead, we could do that. And because we colorize this by their cell type, you may not see this change at all. But if we change the coloring, rather than cell type to be expression, now we can see where this gene was expressed in this UMAP. And again, let's go back to 808. And that changes for that expression level. You can set the colors to be different so that you can use whatever scale you want. So if you wanted a yellow, green, blue scale, you can update to that. And now we see the 808 in this blue scale. But let's go back to the POW2 F1. And now we can see all the different expression colors. And again, there's other options here, yellow, orange, red. A little bit more of a scaling. There's other options, so if we wanted to go into subplots, change the marker size, or miscellaneous, you can. Again, you can change the sort order. This is also an option for this, but because we are only looking at the expression, this isn't necessary. Again, if you want to save it, you can. Save as a new display. And then you can also make it your default again. Let's go back and show you the difference of the tSNE dynamic versus the tSNE static. Or UMAP, excuse me, UMAP static. So we'll stick with the POW2 F1. I felt like the expression was interesting for that one. If you want to see some of the color series and stuff that we can do for this, we can. Let's go back by cell type here, and let's plot this. So this is about the size that this image will be for a dataset collection. And now you can see that these expression values on the left-hand side are shown, and then we also have it colorized by cell type on the right-hand side. And this is extremely useful if you want to show both images side by side. And now, if I do want to change the expression to 808, update that, and now we can see the expression here for that. Go back to POW2 F1 and update. There we are. And we are colorizing samples by cell type. You can choose other things, but for this specific plot, cell type is going to be the most useful. There's a lot of other options you can do here. You can flip, say, the x-axis, which is going to flip the plot. If you want to, you can flip the y-axis if you want to. If you're choosing to do a subplot, you can choose the number of them. You can omit gene expression plot. So if I do that, update plot, oh, excuse me, that did not work. We can change the color scale of that expression plot. Choose marker size as well, and other options. So in the plot configurations, and then there's change colors. So if the color scale that you are loaded with you don't like, you can change this. These are usually set by whoever uploaded the data. So by default, if you recreate this image, it will have all of these colors set because we are going by the cell type. However, let's say you wanted different colors and you save this, it'll keep your saved colors. So you can change these as needed, but this display will only be utilized by your account. If you own the data set, you can set what the defaults are. And another thing, so we can actually create a violin plot if we wanted to from this data. Select some options, X, let's say cell type. So not all plots make sense to do, but you can change them as you need to and see how they show up and play around to create whatever data set or whatever single gene display you need for whatever question you're asking or whatever analysis you're asking. And that is how you create a single gene display in the new gEAR interface. Thank you.